Hello everyone, welcome to GATEBus. In our previous video, we have covered till parabolic 3-hinged arches. Now we're gonna start 3-hinged circular arches. Okay, now let's jump into introduction. As we know, 3-hinged arch means this, right? So as we are discussing about circular arches, let us consider a circular arch with a span of L meters and a rise of H. Okay, let the radius of this arch be R. Okay, let us name this A, B, C. So there will be some horizontal reaction and vertical forces. So for any circular arch, Y will be written in Y. What will be the Y? This will be the Y, right? As we discussed in parabolic arches, Y will be equal to R square minus X square minus R square minus L square whole square. This will be X, right? For any circular arch, this will be expression for Y, and H into 2R minus H is equal to L by 2 into L by 2. This is a property of circle. If you see this, that is, so if it is a diameter, if you draw a chord which is perpendicular to the diameter, then if A and B, C, D, so ratio of A into B will be equal to A into D. Okay, so as we consider a semicircle, arch, so the rise will be here, right? H, and this will be L. Okay, so this is A and this is B. If it is a center, then this will be A and this will be B. So A will be L by 2 into L by 2. C, this is C, right? So this is H. This will be also H, but as we don't know if it is a section here or any other case, that will be 2R minus H. If it is exactly at this point, H will be equal to R, right? See here, this is radius and this will be also radius. If in the question it is mentioned as any segment arch which has radius center at somewhere down to the supports. Okay, for this rise is H, but radius is R, right, which differs. So for this kind, we're gonna use this one, this equation, have expression for Y in the terms of R and X. We can also write Y is equal to C. Y is equal to, so we have to put thetas. So y is equal to r sin theta, then this x will be r cos theta, right? R cos theta. Okay, so let us do this sum. 3-hinged circular arch of span 40 meters and rise 8 meters carries a point load of 120 kilonewtons at a distance of 10 meters from the left support. Find horizontal thrust. So this is the figure for the question. Span is 40 meters, rise of 8 meters from the left support. This is left support, right? So from here 10 meters at 120 kilonewtons point load is acting. Okay, now for this circular r we don't know the radius, so to find radius we're gonna use the above equation. We're gonna use this equation. Okay, that is h is equal to, say, h into 2r minus h is equal to L by 2 whole square, right? So we know h as 8, r we don't know, h is 8, span is of 40, so 2r minus 8 is equal to 20 square by 8, so this will be 8, 50 plus this 8 goes right here, 58 divided by 2, so r is equal to 29 meters. So we got r is 29 meters. Now we want to find VA, VB, to find h. Okay, so firstly we can write VA plus VB is equal to, there is no, so there is a force of 120 kilonewtons, right? And there is no any other force, so we can write this one. Now we'll find moment at any section, so at any support, let it be here, so at M, so from M we can write VB, right? VB into 40, as it is hinged, it can, MA will be equal to 0 and MC will be also 0 and MB also be 0, so VB into 40, this 40, and we have only 120, so it will be equal to 120 into, what is this distance between from A to this point load, it is 10, right? 10, so VB equal to 120 into 10 divided by 40, 30 kilonewtons. So as VB is 30, VA will be 90 kilonewtons, right? So we got VA and VB. Now as we done for parabolic arches, similarly we will do here also. We will find moment at C for arch AC, portion AC or portion CB, and we will equate it to 0. So moment at C for portion AC. So the portion AC, what are the forces acting here is 120 plus H and VA. So VA is going like this, clockwise, anti-clockwise, anti-clockwise. So VA into L by 2, right? So VA into L by 2 is equal to 120 into what will be this distance, 10, right? And this is 40 40 by 2, 20. 20 minus 10, elevate 10. So 120 into 10 plus h into what is the distance between h and c? It is 8 meters, right? So h into 8. So what will we got it? So what we got Vs, 90. So 90 into 20 h 8. So we can see here 98, 90. L is 40 and LB2 will be 20. So 90 into 20, 180 minus 1, 600 by 8, 75. So H is equal to 75 kilonewtons. So this is a circular arch. Okay. Everything is same for circular and parabolic. Only the difference is the formula for y and another equation, this one. That's the difference. So now let's start two hinged arches. Okay, two hinged arches. So let us draw the figure. So this is a hinge and this is a hinge. So we will have VA, VB, H, H. Okay, and there will be no crown. There will be a crown, but it will not be hinged. Just a C. Okay, so this will be L. This is a H. Okay, we can find VA and VB by taking moments at A and B. Okay, then how can we find H? As it is not hinged, we cannot equate this to 0, right? It is not equal. So here moment at C is not equal to 0. In parabolic it is equal. In parabolic moment is equal. Sorry, in parabolic not. In 3 hinged. In 3 hinged moment at C is 0. In 3 hinged moment at C is 0. But in 2 hinged moment at C is not equal to 0. So we're gonna use the formula for H. In 2 hinged, H is equal to integral my dx by y square dx. This is for parabolic, and integral my ds by y square ds. This is a circular. Okay, we're gonna have these formulas now to find H for two hinged one. Okay, in two hinged arc, first we're gonna deal with circular arches. Okay, so let us consider a circular arch. Okay, this is a circular arch. Let this be VA, VB, point A, point B, and point C. H, H, L. This is H. Okay, we're gonna let this be center for this circular arch. Okay, so then it will be called semicircular arch. So let this be R and making an angle theta. Okay, so let us consider a section passing through this point, which is distance x from support A. Okay, this is x. Now if you see this, we call it as phi, this distance from here to here. Okay, so for here y will be equal to r sin theta, right? So see this. Consider this triangle. This is theta, right? And this is r. As we know from trigonometry, this is r sine theta, and this will be r cos theta, right? This. So this is r cos theta. That means from here to here it is r cos theta. So what can we write for x? This whole is r, right? From here to here it is r, and this portion r minus r cos theta. So we can write r minus r cos theta. So x will be r minus r cos theta and y will be r sin theta for circular arches. Okay. So now let us solve a sum. If a point load of W is acting on C, how can we do this? How can we find H? So firstly we can find VA, which is equal to, as it is symmetry, we can blindly say that VA is equal to VB. That will be W by 2, right? So now we got VA and VB. So we have a formula for H, that is, as it is circular arch, my ds by y square ds, right? So ds, if you consider this part as ds, making an d theta, this is r. We know that ds, that means length of the chord is equal to radius into theta, right? R d theta. So we're gonna use this one in this formula. So we have to first find m. What is m? Moment of this whole arch we have to find. So that's why we are using integration. So we'll find m for a section and we'll integrate that. Okay. So see, we'll consider this section and we'll find m. So m at xx is equal to, so we are having VA into this phi, right? So VA into this x, right? X. So what is x? We have written r minus r cos theta. So we got m as r minus r cos theta, and as we know, this line, if you consider this line moving from 0 degrees to 180 degrees, so it covers the total area of this arch. And as it is symmetry, we're going to put limits from 0 to pi by 2, and we will square and we will double it. First we have to find 0 to pi. Okay, 0 to pi we have to find. That means, let's see this, how we will write m by ds, right? We got m as VA r minus r cos theta, right? ds means r d theta, right? So we're gonna put that one, r d theta. So we have to put limits. We have to integrate this arch from 0 to pi. That's so, as it is symmetry, you can see that symmetry, right? So this will be equal to 2 times 0 to pi by 2. VA means W by 2, right? So we'll take common r, 1 minus cos theta. Sorry, here we will have y also. So what is y? R sin theta. R sin theta into r d theta. So 1, 2, 3. There are 3 r's. We'll take out 2w r cube, 1, 2, 3, right? 3 r's by 2. Integral 0 to pi by 2. 1 minus cos theta sin theta d theta. Now we have to integrate this one, 1 minus cos theta sin theta. As you know, cos theta, that cos theta is x, then minus sin theta d theta will be dx, right? So let us let us replace cos with x, that w r cube 0 to pi by 2, 1 minus x. We can write sin d theta as minus dx, right? So we can integrate this. So integration of x, 1 is x, and integration of x is x square by 2. So we're gonna put limits from 0 to pi. I'm solving here. So minus dr cube, x means cos theta, right? Cos theta minus cos square theta by 2, that is 0 to pi by 2. So minus wr cube, what is the value of cos pi by 2? 0 minus 0 minus 1, and this will be 1 by 2. So half minus, here there is minus wr cube by 2. So this is our numerator. We got this part, so this part. Now we have to do the denominator section, that is integration of y square ds. So as we know, y is equal to r sin theta whole square, ds means r d theta, right? We are about pi 0 to pi by 2, 0 to pi. As it is symmetry, we can do 2 to 0 to pi by 2, r square sin square theta r d theta. So we'll have 2 r cube 0 to pi by 2 sin square theta. So we have formula for sin square theta, right? So we have formula for sin square theta, integration of sin square theta. So integral sin square theta d theta will be equal to theta by 2 sin 2 theta by 4 plus c. As we are integrating from 0 to pi, that will be theta by 2 sin 2 theta by 4, right? This is defined integration. So defined integral, we don't have any c constant, that is pi by 2, that will be pi by 4 sin 2 means minus 0, right? Sin pi minus 0 minus plus sin 0 0. So we got pi r cube by 2. So this is our denominator. So we got numerator as this and denominator as this one. So finally we'll get h is equal to pi r cube by 2 w r cube by 2, right? So r cube by 2 get cancelled, w by pi. So h is equal to w by pi. So for circular hinge, if the point load is acting at center, then this h, horizontal direction, will be independent of radius. How much big the arch be or small arch be, it mainly depends on the load, how much the load is acting on the arch. That so h depends on w. You can write a note point over here. As you can write a node point as horizontal thrust for semicircular arch for a point load acting at center is independent of radius. Like that you can write. Let us solve this sum. Determine the horizontal thrust for the given semicircular arch. So we have three loads. It is a UDL, point load, another point load given, right? This is kilonewton per meter, kilonewton, this is kilonewton, right? So firstly we can write VA plus VB solution is equal to 20. So it is acting over half, right? So 20 into 18 plus 60 plus this 40. So what will be this? 20 into 18 plus 100, 460. So we got 460 kilonewtons. So finding moment at A and equating it to 0. So we have VB into 18 plus 18, that is 36, and we have this usual reaction which is coming in this direction. It's clockwise, this is anti-clockwise. So as a constant, so this will be minus, so anti-clockwise, right? This is clockwise direction, so plus 20 into 18, it acts at 18 by 2. We have 60 into 18, right? 40 is acting at 45 degrees, 45 degrees angle, right? So this distance will be equal to, so 60 into 18 plus 40 into this distance. What will be this distance? R. If you consider this is R, this will be R cos theta, right? So R is, we have R is 18 cos 45. Okay, this is equal to 0. So we will find VB here. So cos 45, sorry, is this much into 18 into 40. This is equal to 590 plus 60 into 18 plus 20 into 18 into 9, right? Divided by 36. This is equal to 134.142 some kilonewtons. So VA will be minus 460, right? That is 325.858 kilonewtons. So we got VB, VA. Now we have H is equal to integral my ds by y square ds. So we have to use this formula. So first we have to find this m. So now we have to find m for this whole arch, right? It is not symmetric, so we can't write the equation directly, so sorry, limits directly. So we have to split our limits into some sections. So first we're gonna write the numerator part as integral integral 0 to pi by 2. So for this portion we'll consider an r, we'll consider an sorry, for this portion we will consider a section somewhere between these 2 points. So let it be this one, which is distance of x. So VA into x, series clockwise direction, into, we will not consider these horizontal reactions, as we have to find horizontal. We will not consider horizontal reaction in this formula, in this while finding m. So we will consider this 20 kilonewtons minus 20 into x by 2, right? We don't have any extra forces acting over there. So into y ds. So we have found till pi by 2. So now we have to find from this point to this point. So now we have to find, now we finished with this half portion. Now we have to find from here to here. Okay, so from here 0 to 45 degrees, right? We have 45, 0 to pi by 4, that is VB. So we'll consider a section in this, between these 2 points, which is x, that is distance from support B. So VB into x, so VB into x. So no force is acting here, right? So y ds. Now we'll consider a section between these 2 points, that is pi by 4 to pi by 2, right? We'll consider a section here, which is a x meters distance, same x. This is also x, this is also x, and this is also x. So we'll write an equation. So we'll write a moment for that portion, for the section VB into x, right? VB into x minus 40 into, what is the distance for this? Sorry, 40 into this section, right? Section is from here to here, that is r minus r, sorry, r sin, r cos theta minus x. So for this section we will have theta right here, then this will be r cos theta, and this we know it is given 45 degrees. This will be r cos 45, and we'll get this distance r minus r cos 45. This distance will get, so total r minus this distance and this distance, it will be x. That will be this distance, right? So total r minus r cos theta minus r minus r cos 45, right? See here what I written, r minus, say r minus, total r minus r cos theta. Okay, then r minus r cos 45. So I will get this and this, so I will get this portion. So this will be the equation, so that this will be the numerator for us. Now we have to solve this. Sorry, here y into ds. Now plug in all the values. Integral 0 to pi by 2, right? VA is equal to 32.58 8 into x. This is x, right? So for this section, if we consider this as theta r, this will be r cos theta, so the x will be r minus r cos theta. So r minus r cos theta minus 20 r minus r cos theta whole square by 2, so into y. So y will be r sin theta d theta. Okay, so for this, if we solve this, 325.858 r is 18 into 18, 0 to pi by 2, that is 1 minus cos theta into sin theta. So we left with another r into r, so that is d theta minus 10 into r square and r cube square and 1 r cube, 1 minus cos square whole square sin theta d theta. So we will replace cos as x, so we will get minus sin x dx minus sin theta d theta as dx. So we will replace in this both two integrations. So 325.858 into 18 square is equal to something which is very more 15577.992. So integration, if we do integration 0 to pi by 2, so 1 minus x dx with minus, we have minus, right? So we'll put minus here. So this, for this minus will come into, will convert it into plus. R is 18 cube, sorry, pi by 2, 1 minus x whole square dx plus all this. So this value x minus x square by 2, 0 to pi by 2 plus, so this value, so 18 cube into 10. So if we square this, 1 x square minus 2x, right? So 1 will be 1 plus x square 3 minus 2, 2x square by 2, 0 to pi by 2. So if we put these values, these limits into cos theta minus this value cos 91, cos 91, again 1, right? 1 by 2 minus, sorry, cos 0 will be 0 and cos 0 will be 0, cos 0 will be 1 and cos 0 will be 0, so 1 plus this value cos pi by 2, so theta, right? Cos theta x is equal to, so everything will be 0 minus this 0, 1 by 3 minus 1, so we will get cancelled, we left with this. So we'll have minus, so we'll have this half minus, and again we'll do this, So this value by 2 divided by 2, so that will be 52788.996 plus this is minus this get cancelled and 3 left with by 3, so that will be minus by 3, right? 10 into 18 power 3 divided by 3, 9440, so minus, this is minus by 3, 52788.996, this is equal to 33348.996. okay, so this is our numerator. Now we have to do with integration for denominator y square. So similarly we have to do for y square also, we have to put these limits. So y square means r cos theta, so r sin theta, so r sin theta whole square r d theta 0 to pi, so that will be integral 0 to pi by 2 one limit plus integral 0 to pi by 4 one limit, integral 0 to pi by 4, sorry, here somewhere I think I did mistake, so I have to correct. This is pi by 2, okay, but here, okay, I done only this, right? Okay, we are done with this term. Similarly we have to do this one and we have to do this. Okay, after doing that we have to do denominator, we have to add all those values and we have to do this denominator. We have to split the limits as 0 to pi by 2 plus 0 to pi by 4 plus pi by 4 to pi by 2. okay, let us split these limits, and 0 to pi by 2 r cube, right, sin square theta d theta, so 18 cube theta by 2 minus sin 2 theta by 4, 0 to pi by 2, so r cube pi by 2 means pi by 4, sin pi by 2 means pi is 0, 0, 0, this is the value, so pi into 18 power 3 divided by 4, so we got 458.442, so 2 for pi by 4 to 0 and pi by 4 to pi by 2, and you will get some HS 0.7 point, so you will get H as this value.